Hey there, Python trainer Reuven Lerner here, and today I want to talk to you about interpolation. Interpolation is a technique that we use when data is missing from our data set, and we don't want to throw out some of that missing data. Well, what does that mean? Well, think about it this way. If you've ever tried to get the weather forecast on your smartphone, or let's say find out how long it's going to take you to get somewhere, also on your smartphone, well, it's a whole large connection and network of servers and software and sensors and satellites that are all working together in order to provide you with that information. What if some of those sensors go down? What if some of those satellites are offline? What if some of the servers go offline? Well, then you're going to have missing data. And in every real world data set, you will have missing data. And in the world of NumPy and Pandas, we represent that as NaN. NaN, which is short for not a number. Because guess what? It's not a number. We can't calculate with it. We don't want to even guess what it is. Big, little, so on and so forth. So when you get data with NaN in it, what can you do? Well, one is you can just get rid of it, right? You can just like dump all the NaN data. But maybe, just maybe, you don't want to do that. Maybe there is other data from that given row that you don't want to get rid of. So we can instead fill in the NaN data with other values. And let me give you an example here. So I've already brought up some of this just because it's too long and complicated to type, but I'm going to import NumPy and Pandas and series and data frame from Pandas. And then I'm going to load up data from this file here. And this file I'll show you here is about New York City temperature and precipitation data, all sorts of weather data from a few years ago, back in 2018, over the course of several months. And I'm going to load in 3 of the columns from here. I'm going to load in the date and time, the max temperature in Celsius, and the minimum temperature in Celsius. And so I'm going to read that in from this file name. I'm going to use columns 0, 1, and 2. I'm going to give them names, date, max temp, and min temp, but I'm going to say header is 0, meaning, yeah, I know that the columns are named on this line, but I don't really care. I'm not going to use them at all. So if I run this now, we look at head. So let's look at what our data frame looks like. We have the date and time, and no, I didn't turn into a date time type because I don't care at this point. Max temp and min temp. Okay, so far so good. And by the way, if we look at the shape of this, we have 728 rows and 3 columns. So far sounds reasonable. And now I'm going to do the thing that you should never actually do in production. Here I'm simulating bad things happening. I'm going to say, what if every 7 reads, which would be every 21 hours, we lose the minimum temperature? And what if every 6 reads, which is every 18 hours, we lose the maximum temperature? So I'm going to do those assignments. And now if we look at df head of 50, we will see that we have a whole bunch of NaNs in there. And we can say it's for all sorts of reasons, that the sensors were down, that the servers were down, that the software wasn't working, software does not know how to count to 7, something weird like that. Now what do we do? Well, again, one thing that we could do is just get rid of that whole row. Yeah, we don't need that. We know what the temperature was at 3 p.m. We know what the temperature was at 9 p.m. Do we really need it at 6 p.m.? And some people would say, no, just get rid of it. And in fact, I could say here, df of drop NA. And drop NA removes any row that contains even one NaN. Well, you can imagine not a teensy-weensy data set like this with only 3 columns, but if I had 5 columns, 10 columns, 20 columns, just about every one of those columns is occasionally going to be missing data. So yes, you can tell drop NA that you don't want to drop unless it has at least this number of NaNs in it. It gets really messy really quickly. And this is where we get to interpolation, the point of this video. So interpolation means let's replace NaN values with other values that can plausibly replace NaN. All right? Meaning, we know it's not going to be right, but it's reasonable to say that it could be right. So here's technique number 1. And this is something I learned back in statistics course in grad school. And it's not perfect, but it's a good, quick, a blunt instrument. Replace NaN with the mean of each column. In other words, we can calculate the mean value of max temp, and we can calculate the mean value of min temp, and then we can just replace NaNs and max temp with the mean of max temp, and replace the NaNs and min temp with the mean of min temp. That's hard to say. So how would I do that? Well, if I say here df dot mean, remember that if we, okay, fine. We only care actually about max temp and min temp. So we'll get rid of that textual column. Otherwise, things will go off. And we see here that max temp, 4.2, min temp, minus 1.0. So right there we see what the mean values are. So what happens if I now say df of max temp and min temp dot fill NA, and we're going to fill it in with what I just calculated? Well, fill NA is really smart. If I just fill NA with like a value, 999, it'll replace all the NaNs with that value, that scalar value. But if instead of that, I fill it in with something that I calculated, and not only something I calculated, but a series, then it will match up the columns with the index in the series. So max temp will go to the max temp column, and min temp will go to the min temp column. And now every time we have a NaN, you can see it's 4.21782. And every time we have a NaN here in min temp, it's going to be minus 1.04. And we look at it and it says, oh, that looks actually pretty reasonable. Wait a second. No, it doesn't. So here, 4.21 before 4, yeah, that's kind of plausible. But what is this? That it was 6 degrees, and then it was 4.2 degrees, and then it was 6 degrees again? That's nonsense, right? I mean, I guess it could happen, but it seems pretty reasonable that if it was 6 degrees for a few hours, and then it was 6 degrees after that as well, it was probably 6 degrees in the middle there too. So this is where this version of interpolation kind of breaks down. And technique number 2 is actually easier in some ways. Use pandas, use df.interpolate to interpolate values. Now, the interpolate method comes with a ton of different options. We're not going to look at them. But basically, I can say df.interpolate, and it will return a new data frame. Notice, it does not change the existing data frame. It returns a new data frame in which all of the NaNs are replaced by values. But what values? The mean of the two values on either side of the NaN. So I'm going to say here df.interpolate of head 50. And then we're going to see, actually, let me just first do df head 50. Let's just look at all 50 values here and see where the NaNs are. The first 50 values, that is. And you'll see here 4 and 4. Okay, well, it should be pretty obvious that interpolation will make that 4. And here we have 5 and 5, and interpolation will make that 5. And here we have 5 and 8. Oh, that's a little more interesting, right? So if I have 5 and then I have 8, what should it make it? So my gut feeling, my gut calculation is 6.5, because 6.5 is going to be 1.5 more than 5 and 1.5 less than 8. And it seems reasonable if the temperature was going from 5 to 8 degrees, that along the way, halfway through that time, it would also be halfway through those values. All right, and we can see other places where that might happen. Well, not here in this particular case. Well, I guess if we look at the min temps, we'll see here, actually, don't see it offhand. Fine. Oh, here we have minus 1 to 1. So this could be interpolated as 0. So if I now say df.interpolate, and then I do a head 50, let's see what values we have. Well, I see here minus 1, 0, 1. That's where one of our NaNs was. And I see here, where was it? Here we go, 5, 6.5, and 8. So it interpolated exactly as I would have expected, exactly as I did expect. Now again, df.interpolate does not modify df, so I have to assign it back to df if I want. But it's a data frame that I get back, and thus I can run head and all those other things on it. So this actually works pretty well. But this is, of course, a simple case. Let's make things a little more complex. I'm just going to do a little copy and paste action here. I'm going to say, you know what? It's not just every 7 that have NaN. I'm going to say it's every 5 in min temp, and it's every 8 in max temp that have NaNs. Well, now look what happens. We've got NaNs all over the place. And sometimes I even have 2 NaNs in a row, like here. Well, that's kind of crazy. What's going to happen then? Because think about it. If interpolation says, I've got a value here, I've got a value there, I'm going to interpolate NaN to be the mean of those, what will it do if it has 2 NaNs? Looks like I didn't do a very good job on the max temp. Let's do max temp again to be like 4. That should make it a little more common. Yeah, that will have some. Oh, we still don't have it. All right. I'm going to do this once more. 3. How's that? Yes, there we go. Now we have 2 NaNs in a row. Fantastic. Now we got lots of NaNs there. More NaNs than non-NaNs. All right, I might have gone a little too far, but let's give it a shot. So now I'm going to say df.interpolate, and then I'm going to say head 50. And let's see what happens here. It's going to be 4, and then it's going to be 4.3 and 4.6 and 5. And we know that it's only integer values in the original temperatures. So here it was 4, here it was 5, and it interpolated taking 2 steps, not just 1, to replace those NaNs. Not too shabby. And we can see some other places where that happened. It went from 9 to 8.3 to 7.6 to 7. So when the temperature was going down, it did that as well. And so we can see how it fills in the nans very nicely there. There is still one little issue here, which is the first values here. And those first nans, well, what comes before them, right? And you can play all sorts of games with interpolation if you really want to interpolate backwards, but let's not worry about that for now. At the end of the day, it's only the first values. So I'm going to sort of, just fudge that a little bit. All right, I hope this was useful in understanding what interpolation is, how it works, and two different techniques you can use in Pandas to use it. Don't forget that I come up with new videos on Python and Pandas all the time. I'm on Twitter often, and I have my free weekly Better Developers mailing list all about Python, Pandas, and the like. Join me, love to hear from you, and I'll be back here soon with more videos.